Welcome to Massive Open Online course on basic principles and calculations in chemical engineering. So, we are discussing about computational techniques in module 10, and under this module in this lecture we will discuss about nonlinear algebraic equation system and how to solve those nonlinear equation. In the previous lecture we have described the least square method, how to fit a linear single equation with experimental data, and how to analyze the error of that fitting data with the that proposed equation we have discussed with example. So, here also we will describe about that how to solve that nonlinear equation system. If suppose any nonlinear equation is coming based on the material balance equation or energy balance equation for a particular chemical engineering process, how to solve those. First of all, we have to know the basic principle of that solving nonlinear equation. You know that there are several nonlinear equations will be coming based on that material balance of chemical engineering processes. There you will see set of nonlinear equation like this here as shown in the slides here, like f1 into x1 comma dot 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 xn, that will be equals to 0. This is one nonlinear equation as a function of variables like x1 xn, and another equation like f2 as a function of again those independent variables of x1 to xn, and we can say that similarly there may be more than two equations will coming in the chemical engineering process for its analysis based on the material balance equation, and after that we can recognize this set of nonlinear equation as a f of x that will be equals to 0 like this. Now, each function here in the slides that f as a function of that independent variables of x1 to xn, that corresponds to a nonlinear function. Of course, that will contains one or more of the variables whose values are unknown, which will be calculated by a certain principle. Now, there are major general methods of solving those nonlinear equation systems, like some are successive substitution techniques, some are differential homotopy technique, some are Newton's mostly used that method like quasi-Newton, Newton-Raphson method, even secant method, even Leeuwenberg Marquardt method. Some other techniques also available like graphical solution, even regular falsi method, spreadsheet solution like this. So, here we will discuss about that Newton method, which are mostly used to solve that nonlinear equation. So, here solving a single variable nonlinear equation, how to solve first we have to express. There you will see that if we have that a spreadsheet solution like this here based on that nonlinear equation function. In this case, let us consider that you have to estimate the solution of equation like x will be equals to exponent of minus 2x using a spreadsheet. Now, in this case you will see that the equation here x is equal to exponent of minus 2x is totally that nonlinear equation, where you will see in the both sides of this equation having this unknown variables like x. Here you have to find out what should be the value of x so that this equation will satisfy based on that unknown variables there. Now, in this case you have to solve this equation based on spreadsheet. Like what is that, you have to assume that variables here x, and after substitution of that variables of that assumption value, and what should be the value in that in left hand side and the right hand side will be coming, based on which you will see that if you keep on changing that value of variables, this deviation of this left hand side and right hand side will be coming to reduced or maybe increased. Now whenever you will see that there will be increase, then you have to change the variables x in such a way that your deviation from this left hand side to right hand side will be reduced. So in that direction you have to go, like this here shown in this slide, that if you are considering here the x value as 0.1, and accordingly what should be the function f of x will come, that will be equal to, it will be expressed as like x minus exponent of minus 2x, that will be equals to 0. This is very simple, that it will be x minus exponent of minus 2x. This is basically the deviation of this left hand side to right hand side, or you can express this as a function of x minus exponent of minus 2x, so that your x value, corresponding x value will give you that function of this x minus exponent of minus 2x will be equals to 0 or very near about to 0. Now in this case you will see that if you consider this x is equal to 0.1, you will get this function f of x will be equals to minus 0.7187305753 like this. Similarly, if you increase that value 0.2, its value is coming like this. Here this it is not coming to exactly 0 as f of x is equal to 0, but if you change this value of 0.3, you will see that this deviation is coming to reduced here 0.7 to 0.2 it is coming. Whereas if you keep on increase that value of x here 0.3 to, suppose if you assume here 0.4 to 6156, you will see that this value of f of x will be equal to that is minus 2.73 into 10 to the power minus 4. This is very near about to 0 you can say. So in this case you are getting this f of x for this corresponding value of x here. If you again increase the value of x here 0.5, you will see that this value is coming to increase again 0.13 to 120556 here. Again if you increase that value 0.6, it will increase to 0.29, and if you keep on increasing this value, you will see there function of x that is f of x will gradually increased. So here initially it is decreased and then increased, then it will be it will come here at 0.4 to 6153. It is seen that this functions value is coming almost equals to 0. So we can consider here the value of x will be equals to 0.4 to 6156, which will give you that function f of x will be near about to 0. So in this way we can find out what will be the solution of this nonlinear equation. So this is called spreadsheet solution, but it is trial and error. It will take a lot of time to find out this solution of this nonlinear equation. But you can do by you can use the computational programming, or you can use that computer program by which you can solve this easily, or otherwise you can do a graph x versus f of x versus x. There you will see that where this minimum value of x will be coming, or what will be the value of x will be coming where that f of x will be minimum. So in that way you can also find out what should be the solution of this nonlinear equation. Now we will then do that Newton's method to solve this nonlinear equation, which is mostly used, and this is actually one of the most popular numerical methods, and this is basically originates from the Taylor's series expansion of the function about the point suppose x1 initial point, and in this case if we write that Taylor's series here for the expansion of this function f of x, at this point x1, we can write here f of x1 will be plus f of x1 plus x minus x1 into f of f dash x1 plus 1 by 2 factorial into x minus x1 whole square into f double dash x1 plus dot dot dot. After that, if we take the first two terms of the Taylor series expansion, then we have f of x will be equals to f of x1 plus x minus x1 into f dash x1. Now, we then set equation 2 here to 0, that is f of x will be equals to 0, to find the root of the equation, which gives us like this f of x1 plus x minus x1 into f dash x1, that will be equals to 0, as shown here in the equation number 3. Now, if we rearrange this equation number 3, we can get the next approximation to the root given as x will be equals to then x2, that will be equal to x1 minus f of x1 by f dash x1. So, from this basically what we did here, we took that two terms of the Taylor series expansion there, and after that we are considering that f of x will be equals to 0, and then from which we can find out what should be the value of x. So, this x will be basically the initial value of the next step, that will be equal to x2. So, this x2 will be equal to then x1 minus f of x1 divided by f dash x1. So, here basically what will be the initial value of this x, and minus then function of that x at the value of x1, and also what will be the first derivative of that function at point x1, that you have to take a ratio for that, and then you have to subtract this ratio from that initial value of that x. So, in this way you can get this the second value of that x. So, in this way keep on that assuming that what should be the next value of x just by taking that function at point x, and also ratio of this function to its the first derivative at that particular point. So, if we generalize this condition of that finding the successive x, then we can write here xi will be equals to xi minus 1 minus f of xi minus 1 divided by f dash xi minus 1, where I will be that 1, 2, 3, 4 like this. And since here xi plus 1, that will be equal to xi minus f of xi by f dash xi, and if xi will be equals to xi plus 1, then we can write here xi will be equal to xi minus f of xi divided by f dash xi. So, this implies that f of xi by f dash xi, that will be equals to 0. What does it mean? That at any point x that function will be equals to 0. So, this is the main principles of this Newton's method by which you can solve the nonlinear equation. So, in this case xi is the ith estimate of the root, and successive estimates are then generated with a test of convergence when that function will come to 0. Now, if we represent it graphically, we can then have this diagram or figure here like this. In the y axis we can consider f of x, and in x axis, that is x successive value of x here. If we consider that initial point of that x, then x1, then this is your function simply f of x. So, at this function profile at point x1, what should be the function value? It is f1. Similarly, at this point x1, if you make a tangent at this point, you will see that tangent will intersect this x axis at point x2. Now at this point x2, if you go to that profile here f of x, then corresponding f of x will be is equal to here like this. So this will be your f of f2. Similarly, again at this point x2, at this on this profile, if you make again the tangent of this profile, then this tangent will intersect this x axis at point x3. Now at this x3 point, again you will see that if you consider what should be the value of function here, and if it is represented by f3, then we can consider here at this point f3, again if you make a tangent, you will see there will be a intersection at x axis x at x star, and this at this point of x star you will see that this f of x will be coming almost equals to 0. That means here x star, f of x star will be equals to 0. So in this way you will see that at different point of x, whenever you are making any slope or tangent, and when it intersects to that x axis, that will be your next successive point of x, and at when this functions will be coming 0 at that particular successive points, that will give you the root or solution of that nonlinear equation. So here we can write that f df by dx, that means f dash at xi, that will be equal to fi dash. That fi dash here you will see that when it will intersect that x axis, and at that particular point, if this function x will function f of x will comes to 0, then you will get that final root of that nonlinear equation. Let us do an example here for this. Now you have to determine the root of the equation here. Suppose x is equal to e to the power minus x, using this Newton's method. Now f of x will be equals to basically x minus e to the power minus x. This is your f of x. Now what should be the derivative of this, first derivative of this function? It will be equal to f dash x, that will be equal to df by dx. This is basically 1 plus e to the power minus x, as shown here in the slide. Now when x is equal to 0, f of x is in negative, whereas when x is equal to 1, f of x is coming positive. Therefore we can say that the root x star must be between 0 and 1. So in this case, if we assume that the initial value of x as x1 is equal to 0.2, then first iteration by this x1 is equal to 0.2, we can write then f dash x1, that means first derivative of that function at this point x1 is equal to 0.2, it will come 1 plus e to the power minus 0.2, that means here 1.8187. So what should be the successive point of this x1? It will be coming x2. This x2 will be coming as per this Newton's method. It will be x1 minus f of x1 divided by f dash x1. What is the x1 value? It is given 0.2, and f of x1, that is basically what is that, after substitution of x1 in that function x, it will be coming as whatever value, and then divide it by this f dash x, then it will be coming as finally 0.5402. Now this x2 value of 0.5402, it will be your first or initial gauge of that second iteration. So in the second iteration, the initial value is x2, that will be equal to 0.5402, and then f of x2 will be equal to what? 0.5402 0.5402 minus e to the power minus 0.5402, then it will be coming as minus 0.0424, and then what should be the first derivative of that function at this x2 value? It will be 1 plus e to the power minus 0.5402, then it will come 1.5826. Now with these values of f of x2, f dash x2 and initial value of x2, we can calculate the successive value of x3, which will be the initial value of the third iteration. So this x3 will be equals to x2 minus f of x2 by f dash x2. This is basically based on the principle of Newton's method. Then after substitution of this value, we can get this value of x3 as 0.5670. Now see the third iteration, this x3 will be equals to your first guess of that x value. So x3 is equal to 0.5670, its initial value of this third iteration, and then find what will be the f of x3, that will be coming as 2.246 into 10 to the power minus 4, and then first derivative of this function at this x3 point, it will be as 1 plus e to the power minus 0.5670, it is coming 1.5672. After that, to find out the next point of x, that means x4 here, it will be as per principle of Newton's law, it will be x3 minus f of x3 divided by f dash x3. After substitution of this value of x3, f of x3 and f dash x3, it will come 0.56714. Now see, at this value of x4, you will see that 0.56714, the function f of x is very nearly equals to 0. This will give you the value as minus 5.15655 into 10 to the power minus 6. So it is very near about to 0. So that is why we can say we can stop the iteration here, and we can consider that solution of this equation will be equals to here 0.56714. So in this way you can solve the nonlinear equation by trial and error method as per this Newton's method. Now let us now consider the solving a set of nonlinear algebraic equations involving multiple variables. So till now we have described how to solve single nonlinear equation by Newton's method. Now in this case we will describe how to solve the nonlinear algebraic equations. There will be a set of nonlinear algebraic equations, there multiple variables will be there. So in the we can also use here the same Newton's method that will be used for that multiple equations by modifying this Newton's method, and in this case you have to consider some other some matrix, it will be called as Jacobian matrix for this modification of this Newton's method. So in this case the nonlinear system is to be expressed as a matrix with that corresponding vector as xk, that will be equal to xk minus 1 minus Jacobian matrix at that ka minus 1 of that value of x to the power minus 1 into function of that k minus 1 value of that variable x. So in this case k will be equals to 1 to n, which will represent the iteration. Now so we can say that xk will be equals to xk minus 1 minus j xk minus 1 to the power minus 1 into f of x to the power k minus 1. So this is your iteration procedure based on which you have to find out the solution. Now this f is a vector function and j x to the power minus 1 is the inverse of the Jacobian matrix. This equation represents the procedure of Newton's method for solving nonlinear algebraic equation. Now let us see what should be the function and also Jacobian matrix. Now, instead of solving the equation f of x is equal to 0, whatever we have described earlier, we are now solving the system of f of x equals to 0. In this case, there will be a set of nonlinear equation instead of single nonlinear equation. So, we will now go through the equation and define each component, like here let f be a function of this here f of x1, x2 up to xn, and this a function will be a set of nonlinear equation like f1, f2 and up to fn, where x here represents the vector as a set of this x1, x2 up to xn, and Jx is the Jacobian matrix, which is defined as here first here that means first derivative of that function, that is by which that set of that function is formed. So, it will be dou f1 dou x1 into x into dou f1 by dou x2 into x up to dou f1 dou xn into x. Here x, capital X is basically set of x, where x1 up to xn. Similarly, here in the second row it will come dou f2 dou x1 into x, dou f2 dou x2 into x, dou f2 dou xn into x. If there are n number of equations, then you have to make the derivative of that dou here f of n into dou xn, dou x1 to x into dou fn dou x2 into x up to that dou f n dou xn into x. So, and this is called Jacobian matrix, and inverse of this it will be regarded as inverse of Jacobian matrix. Now, if we consider that steps of Newton's method based on this nonlinear set equation, then we can say that at the first step what you have to do, that here let x 0, that will be equals to x1 0, x2 0, x3 0 up to xn 0, and it will be the initial vector of those variables x1 to xn. And the next step what you have to do, you have to calculate the Jacobian matrix at that x 0, that is initial value, initial gauge there, and also what will be the f of x. And then after that, as a step 3, we have to calculate the vector y 0, where y 0 will be defined as minus of Jacobian matrix at x 0 to the power minus 1, that means inverse of that Jacobian matrix at that x 0 into function x 0. So, you can replace this minus j x 0 to the power minus 1 into f of x 0 formula with the y 0 here, then x k will be equal to x k minus 1 minus j x k minus 1 to the power minus 1, f of x k minus 1 will be equals to x k minus 1 minus y k minus 1. So, this is your step 3, in this way you have to calculate. And then in step 4, once y 0 is found, we can now proceed to finish the first iteration by solving for x1, thus using the result from the step 3, then we can get x1 will be equals to x 0 plus y 0, this x 0 will be equals to x1 0, x2 0 up to xn 0 plus y1 0, y2 0 up to yn 0, these two matrix. And then once we have calculated this x1 based on this x 0 and y 0, we have to repeat the process again until xk converges to x, and this indicates we have reached the solution to f of x is equal to 0, where x is the solution to the system. Now, when a set of vectors converges, the norm is like this x k minus 1 mod of this will be equals to 0, and then it will be defined as this here root over x 1 k minus x 1 k minus 1 whole square plus x 2 k minus x 2 k minus 1 whole square plus up to like this x n k minus x n k minus 1 whole square, and that will give equals to 0. So, in this way we can calculate what should be the, or we can get what should be the root of that or solution of that set of nonlinear equation just by converging to x the value of whatever gauge we are considering as a step by step, and successive value of x as per that Newton's method will give you that convergence of that x, and which will be considering as the solution of the set of nonlinear equation. Now, advantages and disadvantages of this Newton's method to solve this nonlinear equation like this. Advantages of Newton's method is that it is not too complicated in form, and it can be used to solve a variety of problems. The major disadvantage is that this here Jacobian matrix as well as its inversion has to be calculated for each iteration. So, it will take long time to finish, and also calculating both the Jacobian matrix and its inverse can be quite time consuming, that depending on the size of your system. Another problem is that it may fail to converge. If Newton's method fails to converge, this will result in an oscillation between points there. So, there will be a issue for that. So, otherwise it is advantageous because it will not be a too complicated system to solve the equation. Now, let us do an example based on this Newton's method for a set of nonlinear equation to solve. Here is example given in the slides here. Here one equation is like this 3 x 1 minus cos of x 2 into x 3 minus 0.5, that will be equals to 0. Here one equation, this is nonlinear equation. Another equation is given x 1 square minus 8 1 into x 2 plus 0.1 square plus sin x 3 plus 1.06 is equals to 0. And then third equation is given e to the power minus x 1 into x 2 plus 20 x 3 plus 10 phi minus 3 by 3, that will be equals to 0. This is another equation. So, here three nonlinear equation given to you, and you have to find out the solution of this x 1, x 2 and x 3. Now, consider the initial approximation is here x 0 is 0.1, 0.1 and minus 0.1. So, based on this you have to solve this nonlinear equation to find out the solution for x 1, x 2 and x 3. Now, first of all that you have to follow, that is step 1, what should be the initial vector. Since it is given that you have to assume this initial vector as x 0 is equal to 0.1, 0.1 and minus 0.1. This is basically x 1 is equal to 0.1, x 2 is equal to 0.1 and x 3 is equal to minus 0.1 at its initial gauge. Then step 2, you have to define f of x and j x, that means function, set of function and also Jacobian matrix. So, f of x is here simply this is 3 x 1 minus cos x 1 x 2 into x 3 minus 0.5 here, and then here x 1 square minus 81 x 2 plus 0.1 square plus sin x 3 plus 1.06, and then third equation here given. So, these actually made this function f of x, and then Jacobian matrix, simply the derivative of this function f of x based on that variables there. So, it will be coming as 3 x3 sin x2 x3 x2 sin x2 x3 here, and then what is that 2x1 minus 162 into x2 plus 0.1 cos x3, and then minus x2 e to the power minus x1 x2, and then minus x1 to the power minus x1 x2, and then 20 like this. So, in this way you can find out what would be the Jacobian matrix for that initial value. Now, for this initial value of this function f of x0 and Jacobian matrix 0 will be equals to here, after substitution of value of x0 here in the f of x, it will be coming as like this, and then here Jacobian matrix here it will be like this as a transport here. So, it will be coming as this after substitution of this value, this will be your Jacobian matrix, and then to solve this you have to consider that Jacobian matrix x 0 into y 0, that will be equal to minus f of x 0. Now, then using Gaussian elimination method we can have this to solve. After that finally we can get this here for this y 1 0, y 2 0 and y 2 y 3 0 here. Then we can get here y 0 as will be equals to here, as per this matrix it will be coming as 0.40037002 and minus 0.080533314, and then y 3 will be equals to minus 0.42150047. So, here this will be your y 0 as per that Newton's method whatever we have described earlier, and then next gauge of initial value of x that will be equals to x1. This is basically x 0 plus y 0, then it will be coming as as per that matrix rule, that will be equals to here 0.50, 0.01894 and minus 0.5215. So, this will give you what is that x1 value. Again then you have to use this x1 value to find out what will be the f of x at that x1 and Jacobian matrix at that x1 value. So, we can use these results of x1 to find our next iteration x2 by using the same procedure. So, if we continue to repeat this procedure, we will get the following results here for k here 0, 1, 2, 3, 4, that means here iteration number here. For this first iteration it is it is given here, and then second iteration we have found that this value, and then third iteration here what will happen after that x1 plus y 0, it will be coming like this, and then keep on continuing the repetition of the process based on that Newton's method. We can have at different k value we can get this different value of x1, x2 and x3, and then you will see that at this fifth iteration of this you will see that the value of x1 will be coming as 0.5 and x2 will be equals to almost 0 and x3 will be equals to minus 0.52359987, and finally you will see that this deviation xk minus 1 will be equals to 0, where you have to stop the iteration. So, parallel you have to find out what should be the deviation of this xk minus 1, and if it is coming almost equals to 0, then you have to stop your iteration, and that iteration will give you the corresponding value of x1, x2 and x3, and those value will be treated as the solution of that set of nonlinear equation. So, here x will be at that point, it will be equals to 0.5, 0 and minus 0.52359,877. So, this is an approximate solution of those nonlinear equation. Here 3 nonlinear equation, 3 unknown variables, and those 3 unknown variables are 0.5, 0 and 0.523 like this. So, in this way you can calculate or you can estimate the solution of nonlinear equation, and this is the best way to find out the solution of nonlinear equation if there are more than one nonlinear equation. Even you can use that a single equation to find out that solution for its nonlinearity based on that Newton's method. So, we have given here 2 examples and 2 procedure of that Newton's method. One is simple Newton's method, just by gauging this initial value and successive value will be coming based on the function value and its first derivative. And then what should be the second gauge, that according to that principle of that subtracting that ratio of that function value to the first derivative from the initial gauge, then you will get the second gauge. So, in this way keep on repeating that solution of that equation until this function will come to 0, that will give you the solution of single nonlinear equation. But for the set of nonlinear equation, to find the solution here, in this case you have to modify that Newton's method just by incorporating the that is Jacobian matrix, and from that Jacobian matrix you have to calculate the next gauge of that or next iteration of that x value, just incorporating that Jacobian matrix with those function value. And you have to continue this iteration in this method until there is a deviation of this initial gauge to the final or previous that means successive gauge. It will be, if that the deviation is coming 0 for those values of x k minus x k minus 1, then you have to stop there that iteration, and respective value of x1, x2 and x3 will give you the solution of that set of nonlinear equation. So, I think it will be helpful to solve any nonlinear equation based on this method. So, I would further request to follow some example of this Newton's method to solve the nonlinear equation there. And next lecture we will discuss more about that computation techniques. There we will discuss about the numerical integration, how to integrate the scattered data based on some principles that will be discussed. So, thank you for your attention.